Okie dokie, 9.4 represents subtraction of fractions with unlike denominators. So it's very similar to representing addition. We're just taking away instead of combining. Hopefully by the end of the lesson you'll be able to say, I can use a representation to subtract fractions with unlike denominators. Now, I'm going to show you how to use fraction strips because I think it's important that you know what it'll look like at least. If you want to use fraction strips, totally fine, I included a link. If you would rather use the paper pencil method you learned in the last lesson, that is also fine. We'll go over that more next lesson, but it'll work fine for this one if you want to give it a try. So, the problem. Binta needs 2 boards of equal length. How much of the longer board will she cut off? Well, imagining, so like how much is this, right? What's the difference between these 2 boards? Whether I'm thinking about it as the difference or cutting part off, we are going to be subtracting to do that, right? So if we think about what equation could we write to represent this problem, we are doing 2/3 minus 1/2. Now, how can we determine the value of D? How can we determine the value of this number? Well, on your notes, you can see one strategy to subtract fractions is to use and we can write model, right? One way is to find a common denominator, but for this lesson, I'm going to show you how to use a model. So, I'm going to switch over. I have 2/3. Try to think about how I can take away 1/2. So I'm putting it out there for reference. I essentially want to cross off a half. But the problem is, I would just be sort of estimating to see what's left at the moment. I can't, like, there's no 1/2 to cross out because it's currently in 2/3. So that's when I need to find a different fraction to use that I can actually cross off that 1/2. So, you might realize, oh, 6 will work. See, I can turn 1/3 or 2/3 into 4/6. That's equivalent. And now I can cross off equal to 1/2. I can cross off, oops, that one, and that one, and I'm left with that much. So oftentimes you'll see it represented as crossed out. I could drag them off as well, but I wanted to show you what it would look like so that they're still there. I'm just getting rid of them, okay? And then I'm left with that 1/6 as my answer. The hardest part is really figuring out what size pieces to use. Once you figure out the size pieces and you put them out there, it's not too tricky. If I had, say I was doing 2/3, and I just put that out there for reference because it needs to work for both. If I tried, say, 4ths, I'd say, okay, it works for 1/2, but there's no amount of 4ths that are equal to 1/3, right? I need to find something that's equivalent to 2/3, but that is also equivalent to 1/2 so that I can take away 1/2. They just go through that using a different sort of strategy. All right, 3/5 minus 1/2. So again, I'm like, okay, well, I could estimate how much that is, or I can actually go find something that's equal to both. So if I have 3, there's 3/5, right? Yeah. Don't want to do the wrong problem. 3/5. Okay. I'm going to put 1/2 out there again just to see how much I'm going to need to cross off. So I could try some different things. I could try, okay, that works for 1/2, but not for 5ths. If you think about the last lesson, you could count by 5s and by 2s to help you find out what will work. If you do that, you'd figure out 10ths work. Now, if you weren't sure, you could always guess and check with all of them. I'm just kind of speeding up the process. So now I can say, okay, I'm starting with this many 10ths. What is that? 6/10. And then I'm going to cross off what's equal to this much. So that's gone, that's gone, that's gone, that's gone, that's gone. And I just have this 1/10 left. So what is the difference? 1/10.